Alrighty, I guess we'll get started. So I'm hoping you guys had a break and were able to actually take a break during the week you were off. I know some instructors are like, cool, I'm just going to dump a whole whack of assignments on you during your week off. I tried to not do that. Instead, I just made everything right before it, right? I just a little bit of cleanup. I will be marking the tests over the weekend. I'm building a small application to actually help me mark those tests so it goes a little quicker. The benefits to that for you are that I can give you better feedback because I don't have to mark so fast, right? So I can give you more feedback on when you make a mistake, which tends to help you kind of go along. I am a very generous marker. You'll find that out pretty quick. I won't. If something doesn't work, I don't necessarily just give it a 0. I take a look at what you did, and if your syntax is relatively close, I will generally give you partial marks, and then I'll also tell you why you didn't get the full marks for it. So hopefully that will help you become a better JavaScript programmer in the end. Alrighty. Not last week, because we did the test last week, but the week before that, actually 2 weeks ago, we had our first introduction to the DOM, right? In case you forget, that's the document object model. It's the thing that represents our whole HTML page. And every single HTML page you go to in your browser has a DOM. There's a DOM that exists in the background. And it's kind of an important thing to know about because when you're working or manipulating the HTML on your page, you will be using the DOM quite a bit. You already have been using the DOM. Any CSS that you've been working with, you've been manipulating the DOM. Because CSS selectors work like that. They actually work off of the API for the DOM itself. Incidentally, over the week that you guys were off, I was also busy building this. This is a better site. I'm going to load it into the resources. These are all the modules, and I'll be putting these in every week. Makes it a little easier to find the stuff, especially during tests and things like that, when they're all nice and central to one location. That being said, if you go to any of these links, like say, for example, Module 3, and you look, your stuff is gone, right? So unfortunately, your local storage is domain specific. We'll learn more about that when we actually learn local storage. And this is a different domain now. So because it's a different domain, your local storage doesn't carry over. You could copy. Can you export local storage? You might be able to export your local storage and import it. You'd have to look that up. I'm not sure how you do that. Otherwise, you could just practice and fill them out again, right? Which would give you more practice and help you kind of learn a little bit more about it. I don't think I did any upgrades for Module 1 or 2. No, I didn't. Oh, yeah. No, I did. Nope. That's a lie. That's not interactive. So Module 1 and 2 are still pretty static. If I get a chance to come around to them before the final midterm, I will add more information into it and make them editable so that you can work with them. And I will fix this module midterm practice as well because I didn't complete it, but I did get majority of it done. But anyways, busy. All right, let's recap the DOM. All right, so 2 weeks ago, we talked about the DOM. Like I said, the DOM is basically, it's an object that represents our whole HTML page, right? So all the way from the HTML tag down to the closing HTML tag and everything inside of it is represented in an object format in the DOM. The DOM is a standard. It's just a specification that exists. It isn't native to JavaScript or exclusive to JavaScript. The DOM is available through other languages as well. However, most times when people say, I'm working with the DOM or I'm manipulating the DOM, they're generally JavaScript programmers that are talking about it because you will utilize it so much. All right, so we talked a little bit about DOM manipulation, and we explored the query selectors. The query selectors are query selector and query selector all. Does anybody remember the difference between the two of them? How many elements does query selector select? Just one, that's right. Just one. What type of element does it select? Yeah, an HTML element, right? It's one of the HTML objects, right? And that HTML element might be an HTML input element or an HTML button element. But they all extend from HTML element. What about query selector all? Yeah, it's a node list. It returns back a node list, and the node list is made up of what? It's essentially an array of what? HTML elements, right? It's just more HTML elements, just now they're in kind of like a list structure that you can actually work with. So we're going to be doing this quite a bit over the next couple of weeks because we're going to start playing with events, which we'll start doing next week, and you'll find out that you need the DOM in order to work with the events because the two go hand in hand. An HTML element doesn't just extend from, like HTML input, for example, doesn't just extend from HTML element, because you have to follow the chain, right? HTML element extends from node, which extends from the event target. And the event target is the thing that we're going to be utilizing to be able to detect whether a person has clicked or moused over or they've lost focus or gained blur or whatever. We're going to be using that in order to track those events and then perform some functionality based on those events, some interactivity. In fact, we're going to do a little bit today. We're going to do a tiny little bit of interactivity today, mostly because today's lesson is extremely short. It's very small. It's only like 3 things we have to cover to finish up the DOM stuff, and then we'll be into events. So I've created a kind of an interesting lab today, something a little bit different. We talked about the DOM types, right? HTML element, we know what that one is. That extends from element. We have node, event target, and the node list. We had this structure, which basically shows you how they inherit. Each one inherits from each other. We talked about, what else did we talk about? The selection methods. That's the cool thing about Query Selector and Query Selector All. You're just utilizing your CSS selectors, which you guys already know because you've already done CSS, right? So it's nice and simple, very easy to be able to select an element on the page. You can select by the tag name, like input, paragraph, body, whatever. You can select by class, right? So dot button or dot whatever, right? And you can select by ID, which is like the hashtag. You're not limited to that though. Literally think of any type of CSS selector you could possibly come up with, including pseudo selectors. You can use those as selection strings in order to query select a HTML element on the page, which is pretty cool. It's very, very powerful. That led us into the conversation of DOM walking, where we talked about being able to walk through the DOM with the CSS selectors. For example, if you have an LI element nested within a UL and you want to specifically access that LI element, you can use CSS selectors to walk through the body to the UL, to the first child, or whatever it is that you need to do in order to select that particular LI. So CSS selectors, super powerful for walking. That also led us into the conversation about the DOM walking with scope, which is where we pull back an HTML element, and then from that HTML element, we can now do another query selection from that scope point, right? So if we pull back a UL, we can now say ul.querySelector and go find the LIs that are only relative to that UL. It won't reach outside of that scope, which is pretty cool. What else did we do? Scope walking. Oh, we talked about changing the properties of an element, changing its text content, changing the CSS styles of it. We also talked about changing things like, appending and prepending the DOM elements. So basically moving them within our hierarchy, right? And I think that was basically, and then we talked about working with node lists, which is basically like working with an array. There's really not much difference. They are not the same thing, but iterating is almost the same with a node list. You can do for each loops. You can, use for of just like you would with an array. You can run it through a while loop, whatever like that. You have those access points, and you can basically access elements from the node list the same way you would from an array using indices. You can totally do that. It's just important to understand that they are not the exact same thing. A node list is not an array. And then, that was it. Any questions about the DOM from 2 weeks ago? No? Cool. So we're going to basically wrap it up today. We're going to talk about a few pieces about it. We're going to talk about how to, right now we know how to select the elements, and just like many things in programming, you guys know this wonderful word, right? You've heard of that word? CRUD? Yeah. Well, basically the same idea. Not only can we read DOM elements from our DOM, right, from our HTML page, we can also create new ones, We can create brand new elements and stick them into the DOM wherever we want. We can also update them using their style properties or whatever attributes they have. And then we can also remove them from the DOM as well, if we so choose to. So we have CRUD capabilities. That's kind of an important paradigm to understand in programming. You're going to see it in so many different ways. It isn't just married to databases. It is something that you will do in many different ways, whether it's flat file CRUD or whether it's working with the DOM CRUD or whether it's just removing, different elements within a string itself or something like that. You will perform CRUD as a paradigm quite a bit. All right, so let's talk about the advanced DOM techniques. I don't know how advanced they are. They're really not that difficult. So far we learned a lot about objects, properties, methods, inheritance, right? Inheritance, you've seen, comes really important when working with the DOM. I tend to find that most people don't really actually pay attention to the inheritance part of it, and that's because the DOM is not really that difficult to work with. So the inheritance is just kind of there. You're just like, okay, cool, I've got my UL, now I'm going to listen for somebody clicking on it. Well, it's inheritance that's making that capable, right? Because it's inheriting from the event target. It's allowing you to be able to do that. It's not necessarily something you need to focus on. You just need to know that it's there. So I find that a lot of people tend to kind of forget about the inheritance part of it. They also tend to forget that when you're selecting a DOM element, like when you're selecting an HTML element and then storing it in a variable, you're not actually creating a clone of that element and shoving it into a variable. You're basically taking a reference point to memory, right, wherever that actual object exists, and you're just creating a reference point to it. That's it. And then when you're creating direct manipulation, like changing its text content or its style or something like that, the reason why it happens instantly, why it renders instantly in the browser, is because you're affecting the actual object itself, the real thing, the one that exists already in memory, because everything you do is being done through reference. So the DOM is simply an object, right? It's no different than when the objects you create in OOP. There's literally no difference whatsoever. It's not any more magical that way. It's just that your browser actually creates the DOM structure for you immediately when you load up your browser. The DOM is a representation of our HTML page. Provides, like objects do, properties and methods that allow us to create, read, update, and delete various pieces of our HTML element. The DOM is not exclusive to JavaScript, which we already talked about. Understanding the DOM structure allows you to manipulate it with a programming language like JavaScript more effectively. The DOM, however, is not explicitly a JavaScript thing. The DOM was made to be independent of any programming language. And you guys have already worked with the DOM when you guys were working with CSS. All the stuff you did in CSS directly works with the DOM specification. That's why we're able to use CSS selectors as query selectors, because we're doing the same stuff with the DOM. That's all capable because of DOM specifications. All right, recap. Accessing the DOM elements. So accessing the DOM is obviously integral if we want to do any creation, reading, modifying, or updating, especially with existing elements. We essentially the CRUD operations, right? When we access an element, we get an object back that extends from a slew of DOM-related objects. That object will have many properties, right? And we took a look at that a couple weeks ago. So here's some of the selection methods that we were able to use. So the first one is selecting by a tag, right? The paragraph tag. It selects the element from the HTML structure using the p tag. How many elements will that return? How many p tags will that return? Just one, right? And which one? Yeah, the first one. The absolute first one it finds in your DOM structure will be the one that comes back. Same with selecting by ID, right? It's going to find the first DOM element that contains an ID called ID, right? Doesn't matter if it's a paragraph, doesn't matter if it's a body tag, div, whatever. As long as it has an ID tag to it, it will return that element. The first one it finds. Same with the next one. The next one is hashtag ID.em. That's going to return back an element that has an ID of ID and that has a class of EM, right? Just like if you were to select that through CSS, it's exactly the same thing. And it's going to return back one element, and it's going to return back the first one it finds, right? So the one below that, though, the query selector all, it's literally going to return back every single LI within our whole DOM structure. So if you got 60 lists, right, and you've got 7,000 list items, it's going to return back 7,000 list items. And a node list, right? Nice little container that you can now iterate through and do whatever it is that you need to do with it. So generally when you first start out selecting an element, you will start with document. However, you're not married to that, right? Once you have an element back, you can now use it as your scope. And you can use it to still do query selector or query selector all from that scope, right? So why don't we actually do some of this? Come down here to our accessing the DOM, which is our first practice. And I filled in the variable names for you. So the first one says access and store the above UL, this list here, the above UL in the following variable. How can we find out what that UL is? How can we go find information about that UL? Yeah.
Just inspect the page and go to where all the HTML code is.
Yep, that's exactly it. If you right click on it, any one of those list items and hit inspect, you should be able to see the UL parent container. And I'm pretty sure I put an ID in it so that you could select it directly. So go ahead and take a look at that. All right. What's the first part of my syntax here? Yeah, document. We have to use document because we haven't already selected an element, right? So, and what query method am I going to use? Query selector. Access and store the above UL. So we're only selecting one element, so we'll just only use query selector because we only need one back. Now I don't want another UL off the page. I don't want another list. So I'm pretty sure I specified it down to an ID. What was the ID?
M8.
P1?
P1, D1.
D1?
Yeah.
Okay. Cool. Don't hit Command S. All right, cool. So that's going to return back the first UL instance it finds with that ID. If I wanted to get more specific, just in case I did something dumb like put that ID on something else, right? I can get more specific. I could always write UL in front of it like that. So that basically says a UL, an element on the page, tag that has the tag UL with this ID is essentially what it says. It becomes very specific. The more specific you are, the more efficient your query selector will work because the less it needs to run a search algorithm. Okay, so the more specific you are with your CSS selector, the faster that thing will work. Cool, so step 2, using DOM walking and the previously stored UL, right, the one we just got, access all the LIs that have a class of odd and store them in the following variable. Okay, so we can do that simply, equals document, and I'm getting a bunch, so which query method am I using? Yep, query selector all. Anybody want to take a go at the CSS selector for that one? Oh, I wrote document. That's incorrect, isn't it? Because we're going to use scoping. There we go. And I only want the LIs that have the class odd. So what would my CSS selector look like for that? I'll help you out. I'll give you the first piece. There you go. Yeah, dot odd. There we go. And then obviously for the even LIs, should be fairly easy, right? ul.querySelectorAll li dot even, I think it is. I'm hoping it's even. We'll find out in a second. Oh, click execute and I get odd LIs is not of type HTML li element is a type node list. Well, of course it is. That's my mistake. If you get that error, don't worry. What you've done is correct. It's my oversensitive checking by the looks of it. If you want to get rid of the error, you can just remove all on that. Yeah. If you remove all on those, it should say passed. Yeah. Oops. I'll have to fix that before Monday. Or just leave it as all. That works too. This isn't your lab, by the way, so you won't be submitting this, so don't really worry about it. Cool. So that's old hat, right? That's recap stuff. We all know how to do that. I mean, like we can select elements off the HTML page like a ninja at this point. We're all super skilled, right? Let's scroll down a little bit to something brand spanking new. Creating DOM elements. So up to this point, we've only been accessing, reading, right? The R part of our CRUD. We've been reading DOM elements off the page, manipulating them and moving them around, appending and prepending and all that kind of fun stuff. However, we also have the power to actually create brand new HTML elements out of thin air and insert them into our DOM, which then we can actually insert into our HTML page, right? Because anything we add to our DOM structure will immediately render in the HTML page. It's just, that's the magic that happens. The browser automatically does that. The second it detects a DOM change, it manipulates the HTML page and actually inserts the DOM change. So the only thing we need to create new DOM elements is the write method, right? And the write method is called create element. So create element takes one argument. It takes whatever tag it is that you're trying to create. So you think about all the tags. That's HTML tags, right? So paragraph, div, what else? UL, LIs, right? There's tons of different tags that you have the ability to create. So that's all it does. It just takes a tag, and it will return you back an HTML element object known as a document fragment. Not really super important. The one thing you need to understand, though, is when you create it using create element, it's just exists. It's not a part of your DOM yet. Okay? It's just existing, floating in the ether, so to speak. If you want to take it and then add it into your DOM, you're going to have to use one of two methods. One of two methods we've already used before. Does anybody know what those are? How do we move DOM elements around? We have two methods that we can use to move a DOM element from one location to another. Append and prepend. So what we do is once we've created our element, all we have to do is use either append or prepend and append it to an element or prepend it to an element that exists in the DOM. As soon as we do that, the browser will render that new element and we'll see it physically inside our DOM structure. All right. So introducing the document.create element, a method that can be easily accessed on the document object. This method will create an HTML element of the specified tag, or it will create an HTML unknown element if it doesn't recognize the name. So if you give it a tag name that is not technically an HTML element, it won't blow up. It'll create an element. It won't mean anything, but it'll create it. And you will see it in your DOM structure. So if you were to create an element called test, it will create, like with brackets, it'll create this element. Inside your HTML structure, right? And part of the reason that is because the DOM isn't exclusive to HTML. Sorry, it's very dry in here. The DOM is not exclusive to HTML. The DOM also is applicable to XML as well. When you load an XML page, everything we've done with the DOM so far in HTML, you can also do in XML. Everything that we're doing. And because of that, this has to exist because when you're working with XML, you're not restricting yourself to HTML tags. You will actually write tags that make sense to your data, right? That's with XML. So either way, you get an HTML element when you're done. Creating a new paragraph element. Here's an example of how we can create a new paragraph element. Notice we're using the document object. We're starting off with our document object. we call dot create element on it, and we pass it the letter P. So what's it going to make? Yeah, it's going to make a paragraph. It'll make a paragraph tag for us and return it back to us. After that, we can still do the same things that we would do normally. We can manipulate that thing. We can add text content. I have a new paragraph, right? We can then query select another element from our DOM, and we can append our paragraph. And when we do that, what will happen is this thing that's just floating in the ether will now become appended to the body tag, which means in this scenario, appending always goes to the bottom, right? Prepending always goes to the top. That's the way it works. Cool. So there's a link there too if you want to read more about it. Let's talk about adding attributes. We've already done this like numerous times. We've added attributes to our tags before. We've selected elements. This is no different than if we were to select an element, right? However, something I don't think we've talked about before is the attributes like ID, right? We've never actually manipulated those particular attributes, but you can quite easily. All you have to do is take your element that you stored inside a variable and just call that property on it, .id. If you wanted to change the name attribute on like a form element, you would just do .name. If you wanted to do a data element, you would use .dataset and then give it a new dataset attribute. It's very easy to work with these. Style is essentially doing the same thing. When you call style, you're actually manipulating the style attribute that is available to you on any HTML element. So this one shows us changing the ID of the div to Fred. The next one shows us adding a new data attribute. You've seen this before. Hopefully you've seen it before. Maybe you haven't. Depends. If you worked with frameworks, you'll see it quite often. But like, for example, I could have a P tag, right? And I'll give it an ID. There you go. There's the ID. No different than when I do ID equals Fred, right? And then I can give it a data set. So what it would actually create in this scenario would be data dash feeling equals our value, which is happy. Close our tag. Bam. So dataset creates those data attributes. You may not use them very often, but if you become like a Node developer or you're working with React, React uses them quite heavily to pass properties around. Bootstrap uses it massively. So you will see those data attributes, so they're something to be aware of. Text content's a little different. Text content is the text that is currently inside the element, right? And we can actually manipulate that. I noticed that was a bit of a hiccup for some people on the test because it was .value that you were looking for, but a lot of people tried to do .text content, which is not available on an input. So you have to be careful because if it's an input, it's .value. If it's a div, paragraph, whatever, it's mostly everything else. It would be .text content. And then the class list, this is a little different too. Div.classlist allows you to access a list. It's an array basically of the classes. Classes like, I don't know, .button or .primary or whatever, right? And then you can give a list of classes, and then these get appended into the class attribute on the actual div element. Don't worry, we're going to do this. And then the last one, you prepend it. So at the end, when you're done, should look, I don't know if I can get this wide enough to show you. It should look kind of like this. So you should have a div. There's the ID Fred, right? There's the data dash feeling equals hooray. There's the classes that we added, EM, text, practice, and then there's the closing tag element. So why don't we do that? Creating DOM elements. And then after that, I hope you don't mind an early break, but I need a pop or something because my throat is dry. All right, create a new div element. So in order to do that, we're going to do equals document dot create element. That's our magic method. And it takes one argument, and that argument is whatever element it is that you want to create its name, right? So if it's a paragraph tag, it would be a P. If it's a new div, it would just be div, right, for a div. Next, we're going to create a paragraph. So let's do that. We're going to do equals document.create element and create a P for a paragraph tag. So now we have a div and we have a P tag, and they are floating about in the ether. They are not a part of our DOM yet. We haven't actually added them to the DOM structure. Okay? So you can't see them. You're not going to be able to see them yet. You have to wait for that until we finish up, and then we append them or prepend them, right? All right, cool. So step 3. Change the text content of the paragraph. All right. So p.textContent equals hey there, or whatever you want to do. Totally up to you. And then step 4, change the color of the paragraph. Okay, well, we know how to do that. p.style.color equals pink, or whatever you want. And then we're going to do something kind of neat. Even though these two elements are floating around, right, and they aren't actually a part of the document object yet, they're not a part of the DOM yet, what we can do is we can still work with these as if they were proper HTML elements. We can take that P tag and we can append it to that div, even though neither one of them are actually a part of the DOM yet, right? And all we have to do that, it's so simple. We just do div, append, P like that. So now our paragraph that we created is sitting inside the div. It's now nested inside the div that we created. So those two things are now together, right? And then I've done this selection for you. I've query select this object for you, or this HTML element. All we're going to do now is append the div to this HTML element. So we just do m1p2sr, right? Dot. And what's my magic word? Append. And what am I appending? Yep, div. And if you did it correctly, you shouldn't get an uncaught red error. Cannot append null. Actually, this is a good point. These weird errors are technically kind of backwards how they're being written. What it's saying is it can't append, cannot read property append of null. That's not an issue with our div, right? What is it an issue with? What is the problem object inside that statement? What is likely null? What's that? Nope. Nope. This thing. If you read what it says, cannot read property append of null. Meaning this is null. And we can actually see that. I can actually show it to you. I believe it's M1P2. Interesting. Yeah, I think I know what's happened here. Oh yeah, definitely know what's happened here. I have not pushed changes. Hang on 1 second. Or maybe I did. Why is it not showing up? Oh, right, M8P2. My apologies. .env. Yeah, there's an issue there. All right, not hugely important. As long as it looks like that, that is correct. So this is our object that's sitting inside our DOM. this actually exists in our DOM. It's an actual HTML element that is currently inside the DOM. It's not floating in the ether, right? But we want our div to be actually a part of our DOM. So in order to do that, we can append it to the M1P2SR. So because we actually want to see this thing, why don't we inspect? Let's see what we've got available to us here. Yeah, there's the div right there. M8. Oh, there's our problem. See how it's M8P2SR? Why don't we just change that? So it's M8P2SR. What's that? Yeah, we're going to change the ID. Yeah. M8P2SR. So now that should select a proper element. M8P2SR. M1P2 is not defined. But I get hey there afterwards. I mean, I'm happy. We've got hey there. That's fine. Did you get hey there or no? You did, though? Yeah. Just double check that your syntax is using M8P2SR. I mean, I got to find better, more human readable names instead of M8P2SR. It's a little tricky to remember. All right, just to quickly recap, we created a div, and when we created it, is it a part of the DOM? No, not yet, right? It's just floating in the ether. Then we created a paragraph. Is that a part of the DOM? No, it is not. We changed its text content in the paragraph. We changed the color of that paragraph. Then we appended the paragraph to our div. Is our div now a part of the DOM? Nope, not yet. Not quite yet. It still is floating in the ether, but our paragraph is now nested inside that div. It's totally a part of it. In order to get this div to be actually attached to the DOM, we need to select an element that is currently a part of our DOM, right? Like this M8P2SR or the body tag. If you wanted to do that, you could use the body, or you could just grab a random div somewhere. It doesn't matter, as long as it's currently a part of the document object, right? Then all we have to do is call append, and we append our little floating div, and it now becomes a part of our document object. See? Hey there. And it's actually married in there. And if you right-click on it, choose Inspect, you'll see there's our div that we created, and there's our paragraph. Yes, Kabal?
Can you just press again exit, because I think it's adding the big tag. Okay.
Oh, is it?
Yeah.
Yeah, if you do execute, it'll just keep doing it. You can just.
Yeah.
So now there's like a whole pile of them. Yeah. So that's because we're doing append. So there's another option if you don't want it to duplicate like that. You can use dot inner HTML like that. And that will actually replace the inner HTML with whatever it is you're doing. So I'll show you in an example what that looks like. So we can say, instead of this, we can say inner HTML. And it's unfortunately not a, it's not like a function. It's like text content. It's almost equivalent to text content. That's not going to work very well, is it? We would have to fix that. Yeah, my brain's not thinking about that right now. I can't figure out how we would fix that. Yeah, can't think of it off the top of my head. We'd have to basically create a template out of it and then clone it. So that'd be odd. Let's just leave that as a pen for now. Simpler to understand. I mean, we are going to work with templates. That's our next part. But before we do that, I need a pop before I cough my lungs out. And then, yeah, and then we'll do that. We got some fun stuff today, though, which will be nice. I'm going to pause this. Okay, we're going to talk about working with templates. So up to this point, we've been actually, like, we were creating DOM elements, but there's kind of a problem with that, right? Creating HTML makes it very difficult to maintain that HTML you create. Because it can grow exceptionally large after a while. Like, for example, we built this site for this company called Distributors, and at the last minute, they wanted these like notifications that would show up, and we were like, okay, we can do that. So we were using this library that basically in the library, it created the HTML block, and then it would append it to the page and make it show up with the notification. But it created the HTML block. And they didn't like the style. The style of it was not what they were looking for. So we tried to target it with styling, like with CSS, and we got so far, but we found out we needed to add another element to it in order to make it better the way we needed it to. But that proved problematic because they didn't use HTML in an HTML page and then just pull it in. They were writing their HTML in their actual library itself. So we had to go track down where that HTML was being written and then modify that HTML, which we didn't wind up doing. We wound up doing that whole document.create element, and then we appended it to this thing. And it was a mess. It was hard to maintain. It's very gross. It just doesn't look good. The better way is to use something called templates. HTML5 supports this new element called the HTML5 template. And it's just a regular HTML element, no different than you're used to seeing. It looks exactly like this. Template, just like that. It's just a regular HTML element. There's no difference between it and a div or anything else. That's not entirely accurate. It has one difference. And that difference is it doesn't get rendered by the browser. So the browser will not render any of the contents inside a template element. The convenience to that is you can put blocks of HTML into your HTML page and then use those blocks to render them when you want to with JavaScript. But the nice thing is you're keeping your HTML out of your JavaScript. So you can easily maintain that block, change that block, do any editing you need to do in the future with that block without having to modify your JavaScript. Okay? So templates are really handy. They are supported pretty globally since IE 10. However, if you're trying to support browsers like IE 9, unfortunately you don't have template available to you, but there is something known as a polyfill library. Polyfills are kind of something you should be aware of. What a polyfill library is it essentially says, this browser doesn't have this function, so I'm going to create a function using things the browser does understand, and I'm going to inject it into the browser at that time. It's a little slower than the browser having it natively, but at least it gives that browser support until that person upgrades their browser, and so on and so forth. Generally, we don't support IE9 anyways. We just give up on it and say forget it, or we charge a lot more money if people want IE9 support. But just be aware that polyfills are there. All right, cool. Let's do some stuff. So I'm sure you can see the issues of creating HTML elements in code. 1, super tedious, right? 2, not very maintainable. Plus that annoying bit where we're actually taking our HTML and mixing it up with our JavaScript. We ideally want to keep things uncontaminated. That's where templates come in. HTML5 introduces the template element, which will allow you to add a non-rendering HTML element to your HTML page. You can then access it with JavaScript and work with it as you would with any HTML element object. However, there's one caveat to it. Because it is an element, right, you can't just grab it and append it somewhere else. Because if you do that, all you're doing is just moving it through the DOM. You're just moving this thing that doesn't render and jamming it somewhere else in the DOM structure. So it doesn't matter. What you want to do is you want to do something called clone. You want to actually take that element and you want to clone it and create a copy of it that you can now render inside your DOM structure. So this is basically what they look like. Template, div, I am redundant. That's another good use for template objects. You have this element that is going to be redundantly made over and over and over again, so you can make it a template and then use JavaScript to render it, 5 million times through a loop or whatever else, right? So you need to be aware of that. So that thing says, I am redundant. Here's how we work with the template in JavaScript. First, we select the template the same way we would select any HTML element on our page. There's no difference to that part. Using document.query selector, we select the HTML element that just happens to be a template. Okay? The next part, we take that and we use a method called import node. We pass import node, our element, so you can see temp here is getting passed into here, and we're calling dot content on it. And what dot content is literally the whole contents of that template. Everything sitting inside that template. Okay? We use true, and what true says to import node, I don't want just this div. I want the div, and I want the paragraph, and I want the text node that you're rendering inside. I want you to recursively dive through that DOM structure and pull the whole thing back. I want all of it. That's what true means. If you don't pass true to import node, you will only get the div part. That's it. You won't get the rest of the structure. So if you want the whole structure, you got to pass true. So that will actually take the node. It creates a document fragment, the same as the create element creates exactly the same thing. Just this thing that exists in the ether. It's not a part of our DOM yet, right? It's just floating around in space. In order to make it a part of our DOM, we select an element that is currently on our DOM, like the body, and then we append it. So the only difference, the only thing that you don't know currently is the import node part. You know how to select elements on the page. You know how to append elements to a page. You've learned how to create things, right? That's exactly what we're doing here. We're creating a new element using import node that's just going to basically be a mirror of whatever's inside our template object. All right. I mean, doing it makes more sense. It's a little easier to get accustomed to it. So select and store the template. So just copy this silly thing. So we can store it in any variable we want. We're gonna use const, right? Why don't we just call the variable that? Document.query selector hashtag command B. There we go. That'll select our template object. And you can see the template on the page if you want to. I think if you scroll down to just below this and right click and choose to inspect. So if I just inspect here, there's my div, there's my article. It's probably in this section. It's in this section. There it is. There's the template object right there. There's its ID. And inside of it, there's some stuff, right? Already a document fragment too, I might add. There's a little thing in there called cube. Cool. All right. Iterate 9 times starting from 1 and ending with 9. Okay, so we're going to go 4, right? Let I equal 1. If I is less than or equal to 9, I plus plus. That means I, the first iteration, will be 1, and on the last iteration, I will be 9. Clone the template. Okay, cool. So let's create a new variable. We'll call it clone. We use document.import node, which is our method. And inside there, we're going to put m8p3 temp dot. And what property do I need from it? That gets me all the stuff inside of it?
Content.
Yep, content. And what's the last flag I need to pass so that it does it recursively? Yeah, true. So that's going to do a nice deep dive into that template, pull all of its contents out and bring them back to me. The next step is to assign the current number to the template's .num element. Okay, so that clone, we've imported it back. It has a .num on it, so we can easily do that by just going clone .query selector we're going to grab the num class. And there's no reason for us to store it, so we'll just do text content equals I. So that's grabbing the class using scoping, right? So clone is just an HTML element, no different than any other HTML element, right, that we create. Using its scoping, we're accessing an element inside of it that has the class num, right? We pull that back, and then the reason why we're able to do .text content is due to something called chaining. So the first piece returns, and then we can immediately chain onto it and do another step if we so choose to. If you want more better context so it's easier to read, what we could do is let, I don't know, temp equal, and then temp.text content if you wanted to break it up into two separate pieces. But I mean, I find it just as easy just to chain it. So Java support chaining? It must. Where you can perform a method and then chain on the next method and it will return the result set to the next one? No? Yes? No? Okay. Step 5, append the clone to the hashtag M8P3SR. So we're going to use chaining one more time. We're going to do document.query. I'll move this up a little bit. Selector hashtag M8P3SR. And like I said, there's no reason for us to go one extra step and store it and blah, blah, blah. We'll just call append, right on it, and we'll pass in temp to it. You can also pass in clone to it because it's all reference anyway. All right, and when you're ready, you should be able to hit execute. And you should see 1, 2, 3, 4, 5, 6, 7, 8, 9 at the bottom of the screen. Because each one should wind up in there. And this thing's not working because we did some extra kind of funkery, but don't worry about it, I don't really care. As long as you have 1, 2, 3, 4, 5, 6, 7, 8, 9, it's worked. Okay, let's do a quick recap. So we selected our template, right? This is our template here. And you don't have to just select a template. You could select another DOM element and then clone it if you wanted to. So this is not exclusive to templates. You can literally clone any DOM element that's on the screen. Next, we iterate 9 times and we basically create 9 instances of our template. That's what we're doing. We're importing it and we're cloning it 9 times. Each one, we're selecting the element inside of it that has the class num, and we're setting its text content equal to whatever current number we're on inside our for loop, right? So the first time we iterate, that number will be 1. The last time we iterate, it'll be 9. Then we append the clone to this element that we've selected, and it gets rendered to our screen. And it happens stupid quick, right? I mean, if we could slow it down, or if we could speed ourselves up to computer speed, we would see it literally draw 1, 2, 3, 4. But I mean, we can't. We're not going to do that. We could always add a delay, like a timeout, make it wait for it. It's always an option too. All right, cool. I mean, cloning templates will happen. You will wind up having to do it at some point in your career if you decide to become a JavaScript developer. But it's not something that you'll see all the time. I always have to look it up. Every time I need to do it, I always have to look it up. This, however, removing DOM elements, pretty simplistic. Often there's a DOM element on the screen that you're going to want to get rid of. And we can do this quite easily by first just selecting the HTML element, whatever it is, using query selector, and then you literally just call .remove. That's it, and that's gone. The caveat to this is it's gone. It's not coming back. You can't get it back. It's not like you can do remove and store the results into a variable that doesn't exist. It literally removes it from the DOM and it's gone. You're not getting it back. Now, JavaScript is stateless, right? So how could you get it back if you really needed to? Refresh your screen, right? Just refresh. Because JavaScript is stateless, and then everything comes back and like magic, right? But it's important to understand that .remove is destructive. It's a destructive thing. So if you write code that removes a DOM element, it will remove the DOM element until you remove that piece of code. So let's take a look at how it's done. It's very simplistic. All we do is query select whatever the DOM element is that we want, and then we do remove. Now, if you do body remove, that's pretty tragic. I'll show you what happens. Let's do, we'll just write this code right directly in here. Body equals document query selector. Body tag, right? Cool, I've got my body. Now I'm going to do body dot remove. That's what happens when you remove the body. Takes everything, right? Because everything is nested inside the body layer. It's gone. It's not coming back. If I choose inspect, I have a head tag. I have no body tag anymore. It's gone. If I want to bring it back, just refresh, right? It's JavaScript. I mean, the web is stateless. The only reason why you guys are able to execute this stuff and have it stick around is because I store it in your local storage for you, which is like temporary storage, basically. But yeah. All right, so let's remove some stuff. So I've got like a list of 4 numbers here. We're going to remove some of them. We're going to select and store all the span tags and the hashtag M8P4DM tag. So I'm just going to copy that because there's no way in hell I'm going to remember that. So I'm going to do that. Bam. Equals document.query selector all because it wants me to grab all the spans. Actually, I'm going to change that. I'm going to call that spans. Makes more sense. And my selector will be that and span. So that space span is what it will be. Now, if you find that these extra long lines are kind of annoying and you want to be able to like clean it up and make it look a little cleaner and nice, JavaScript supports how to write it. It basically will interpret the statement until it hits like a terminating line. So it's going to look for the semicolon. If it doesn't see the semicolon, it will continue on to the next one unless it's a logical termination point. Because of that, you can kind of take advantage of that, and you'll see this quite often, where people move the next statement to the next line. And that becomes especially more prevalent when you start chaining. If you're chaining things on, you'll see people just drop them to the next line so that they can just continually chain it. Makes it a little cleaner, a little easier to read, right? If you're not keen on that, just butt it right back up against the document. That's totally fine. Just be aware that you can do that. All right, iterate over the spans and remove each one. All right, so we can do this in many different ways. What have we not done in a while? We haven't done a callback in a while, so let's do a callback. So we're going to do spans.forEach. For each is a method that takes a callback. So we're going to need to write function. Okay? Callback is simply just a function. That's all it is. It's a function as an argument. So instead of passing a string, you're passing a function, right? Instead of passing a number, you're passing a function. And what's cool about that, for each is actually going to call this every single time it iterates. So it's going to iterate over the span, it's going to get a span, it's going to call this, and whatever span it's currently working with, it's going to pass it in as an argument and make it available to us. So we might as well put a placeholder in there to catch it. And common, you just call it span, usually. I mean, you can literally call it whatever you want, Bob, Louis, whatever, it doesn't matter. It's just variable, just placeholder. And then common, like conception is to do this, where you basically put a nice blank space there so that you can actually write your logic right? And all this logic, it's the logic that's going to execute on each function call. So we're going to just, it's very quick and easy. Span is an HTML element because spans is a node list. And dot remove. That's literally it. And when you execute, ba-doop, all the numbers have disappeared. And you should get a pass. It's like the first one out of the whole damn lab. I mean, this isn't the lab, but whatever. That's a callback. I know callbacks can be confusing, and we have brought it up like several times, what it basically is. We're going to write so many in the next upcoming weeks because events pretty much use them all the time. All of our iterators will generally use them, so you're going to have to get used to this because we're going to be doing it quite a bit. But essentially, all a callback is, if you're familiar with lambdas, you already understand the concept of a callback. If you're not familiar with lambdas, all a callback is a function that calls a function, right? This is a function. For each is a function. And all it's doing is calling this function. Okay? I get it, it's confusing. That's totally fine. So why don't I make things less scary, and we'll go build the tic-tac-toe game. Sound like a plan? Click that link, and you should hit here, tic-tac-toe, a game of skill. Yep.
So we want to talk about the callback functions, right?
Yes.
So we use the normal functions. So there are also arrow functions. So what is the difference between normal functions and arrow functions?
Because if you aren't already confused, you're about to be extremely confused. Okay, so in JavaScript, you have regular functions, right? Regular functions, they work by, how to put it? Here, let me erase this. Okay. A regular function, it's better to think of it from a method perspective. A function, like the ones that we created before, with the function constructors, right? Hi. This function, the context of this, remember our magic keyword this? The context of this is owned by this function. So if I call this inside here, it's referring to that at all times. Okay? Same thing. Arrow function. This looks exactly the same as this. They look identical, and they will function for the most part identically. However, if I attempt to access this from in here, this is going to go to whatever owner object is up here, which is likely the window at that point. Arrow functions don't control this and scope it to themselves. They scope it to whatever they're contained inside. That's where the confusion lies. People get very confused with arrow functions. That's why I don't tend to focus on them too much during this class. However, when we do advanced frameworks and we're working in Node and stuff, these things are fantastic. They become extremely handy. They make life very simple because you don't have to do binding and stuff. So we'll be doing them almost exclusively, arrow functions all the time. These are available to you. If you are curious how these work, you can write these. If we were to write the same one that we just did with the arrow function, so here we are, we've got our spans right up here. I'm just going to comment out this code because I don't want it to execute. There we go. If I write the same thing with an arrow function, it would look like this. Spans for each, and I can just write that like so. That's the same statement. And we'll do exactly the same thing. A lot cleaner though, a lot quicker to read. Works, but you just have to understand that the context of this gets changed. So it can be a little confusing for newer JavaScript programmers. All right, ready to write tic-tac-toe? Let's write some tic-tac-toe. Tic-tac-toe. Now, this is going to be similar. It's not going to look exactly like this one. Week 03. It's not going to look exactly like this. There won't be any artificial intelligence in it, even though this isn't really artificial intelligence either. It's just good logic, I guess. You can always review this if you right-click. If you ever want to know the JavaScript that's powering something, you can always go to View Page Source on it. And down here you can see opponentai.js. If you right-click and choose to open in a new link, there's the code for it. So if you wanted to see how that AI was actually running, you can just inspect and go take a look at it directly. But anyways, it's also inside my GitHub, right? So you can always go to the GitHub as well. But the idea is that you should be able to place a letter. Player 2 should be able to place a letter, and it should reverse back and forth. The logic behind tic-tac-toe is fairly simplistic, so I figure it's a good one to start with. It shows you that the power of the DOM is there. We can actually do a lot of things with the DOM, which is kind of cool. There's no hinting in this. It's not going to give you any information. And we might as well zoom out a little bit so it at least shows up correctly. The code block for this will be your lab. So you'll just select this whole big giant code block and paste it in the submission. And it will show up over here on the left-hand side, our finished product. This will go pretty quickly. I know it looks like it won't, but it'll go pretty quickly. All right. Step 1, create a function constructor called tic-tac-toe. So you remember how we created function constructors and those were our objects, right? Essentially like a class. We treated them kind of like classes. They had properties, they had methods available to them and stuff like that. I was going to write this just simply with function, 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 function. And then I thought, you know what? We already know how to create objects. We might as well utilize it because it helps reinforce that concept. So that's what we're going to do. We're going to create an object function. So I'm going to pull this up just so this goes a little smoother. One moment here. File. Need my public JS. No, examples. Cool. All right, so the first piece we're going to need a create our function called tic-tac-toe. So we're just going to create an empty one. We're going to do function. Oh, I see what I did. Hold on. Sorry, my apologies. Takes me a second to get tracked where I am. We're right here. We're going to go function, tick, not eek, tick, tack, no, all one word, tick, tack, toe. Hopefully you can read that. If you can't, please just move up. I don't know if I can get in any closer without it breaking the side. Yeah, I'm like, that's the maximum I can go to without it breaking the thing on the side. All right, so that creates the function, like function constructors are. They're just functions. That's all they are. We're going to give our function a parameter. And our parameter is going to be an optional parameter. I'm not sure if we talked. Yeah, we did. We definitely talked about optional parameters in a function. It's just the name of the parameter, but you give it a default value. We're going to give it the default value of an empty object. Right? This will allow us to kind of manipulate the tic-tac-toe game if we so choose to. All right, step 2. Initialize the starting player. Alrighty. We're going to do this because this is going to be a property of our object, right? We're making a function constructor. So it's going to be a property, and we're going to call it current player. Hello, player. And we're going to make it equal to 0. Now that seems weird, right? Game has 2 players, player 1, player 2. But we're going to think in indices. We're going to think like arrays, right? That'll make things a lot easier for us when we're dealing with the player's pieces, with the player's score, stuff like that. Way simpler to just think in indices, which means player 1 is actually 0 and player 2 is actually 1. right? Just makes things a little simpler for us. You'll see as we go. Step 3, initialize the player pieces with either the property player pieces found in options containing an array of 2 pieces or a default array containing 2 pieces. So what I'm basically saying here, when they initiate the game, they could pass in a property in here with any 2 pieces they want. Maybe they want to use S and N, right? Instead of X and O. That's totally possible, right? We're going to give them that ability to choose whatever player pieces they so choose, or we're going to default to X and O, okay? So I'll show you how this works. We go this dot player pieces, right, which is just a property that we're setting on our object. And we're going to encapsulate our logic into a set of parentheses. We're going to first check the options that are passed and see if a player piece's value exists on it. That's our first step. If this has player pieces property inside of it, we're going to wind up utilizing it, right? Otherwise, and what's really cool, this is like kind of like an inline if condition. We write an or statement right there. By the way, that is badass logic. Learn to write short. That is cool. And almost every programming language supports that. The ability to write this or this. All directly in line. No need for an if condition. You write it right directly in line. And it'll return whichever one is appropriate. And obviously we're going to give it an array as our default. X and O. Cool. Now, if you want to save, scroll to the bottom and click execute, and that will write what you currently have to local storage. That way you don't lose that content. Yeah. Sure. So essentially the way this works, say I have a variable called x, right? And x is equal to false, right? And then I have a variable called y, and y is equal to 5. So I have x and I have y. X is false, y is 5. If I do x or y, what do you think it will return? What's that? What do you think it will return? You think it'll return false? Because it's going to read the first thing, right? Okay, so that's the cool thing about this. It's going to return 5. What it does is it evaluates the left side and says, are you true or are you false? Now, false has to be explicitly false. False, null, or undefined. Has to be one of those 3 things. It cannot be anything else. If it is a value, it'll return the value back. Whether it's true, 5, Sean, whatever, it'll return it back. Otherwise, it's going to go to the right side and say, what are you? Are you false? Are you true? Do you have a value? If it's false, we're going to get back null. That's just what will happen. But if it has a value in it, we'll get back the value. And you can see this as well. If we do y or x, we get 5 because y is true, and it returns it back immediately. It's pretty cool. You can also do it with and. You know, like the double ands? The problem with this one, though, this one works a little slightly different. What this does is it evaluates both sides. Both sides have to be true. If both sides are true, it will return the right-hand side. So if I have x, which is false, and y, I don't get anything. But if x had a value in it, and then I did x and y, I get 5. I get the right-hand side. Confusing, but it is a very powerful shorthand, and it's worth knowing. It's definitely worth knowing, because you'll see it quite often. So what this is essentially doing is it's checking our options that we passed up here, and it's looking to see inside this object whether or not there is a property called player pieces, which allows our user who creates this tic-tac-toe game to pass in their own player pieces. They can pass in their own player piece array and then utilize that. So SN, JV, whatever the heck they want. Maybe XX, wouldn't that be confusing, right? They can pass in whatever they want. Otherwise, we want to default to X and O. Okay? We'll do it a couple more times, actually, through this thing, I think. Yeah. Next, we're going to need the win condition. So instead of, like maybe some of you are really, really good at math. I know you said you were good at math. And maybe you know magic square really well. I don't. I do not know magic square. So we're literally going to program all of our win conditions in. Don't worry, there's only 8 of them. There's only 8 possible combinations that you can have. So it's really, really easy. So we're going to do this dot win conditions equals, we're going to store it in an array of arrays. All right, first win condition. So think of our grid, right? Let me write our grid down, and then you can see what we're doing here. So we're only working in a 9x9 grid. Nice and simple. And we're going to think in arrays, okay? 0, 1, 2, 3, 4, 5, 6, 7, and 8. So let's think about the possible win conditions, right? So tic-tac-toe, for those of you that don't know, which I'm pretty sure the game's fairly universal, but if you don't know, tic-tac-toe, you got to get 3 in a row. That's the idea, right? So 0, 1, and 2, right? That's 1. 3, 4, and 5, 6, 7, and 8. So there's 3 possible win conditions, okay? 0, 3, 6. That's 4th. 1, 4, 7. That's 5. 2, 5, 8. That's now 6 win conditions. 0, 4, 8 brings us to 7. And 2, 4, 6 brings us to 8 possible win conditions. Okay? So we're going to just basically hard code those 8 win conditions. So the first one, 0, 1, 2, comma, and that goes in an array. 3, 4, and 5. 6, 7, and 8. 0, 3, and 6. And use the board as a reference if you need it. 1, 4, and 7. And make sure you put your commas after each one of these, because it will blow up. What else? 2, 5, and 8. Whoop, means brackets. 0, 4, and 8. And square brackets, 2, 4, and 6. And that probably would be a good time to scroll to the bottom of the page and click execute, so you don't have to write that again. You know what, we're so past our board anyways, I'm just going to zoom in a bit for you. There you go. Make it a little easier for you to see. Now there are equations, and if you take a look online, there's even a Wikipedia article on the algorithm behind solving they call this a magic square, solving this magic square. But I mean, it's extremely convoluted. If you are skilled at math, feel free to go take a look. And if you figure out a way to write the code for that, feel free to send it to me, because I'd love to see it. I think it'd be really cool to see. As far as I'm concerned, this benchmarks almost as fast, if not slightly faster, because it doesn't have to perform any algorithms. It's just merely checking, doing a lookup. Right? So it's super, super, super fast. All right, cool. If you haven't already, scroll to the very bottom of the page, click execute. That should save it to your local storage. I'm going to do myself a favor and Command-C that before I try this wonderful attempt. But I'm going to refresh. Yep, and everything's good. So you don't need to refresh. Just make sure you click that execute so it goes into your local storage. All right. Anybody still writing out the win conditions before I scroll a little bit? No? Okay, cool. Step 5. Initialize the plays property that will store the total number of player plays. So Why are we storing the number of plays? I think we're storing the number of plays to tell whether or not it is a draw, if the game is in draw. So how many possible plays can there be? What is the maximum number of plays? 9, exactly. So if our player plays is at 9 and nobody's won, then the game's a draw, right? That's basically the logic behind that. So we're going to do this dot plays, and we're going to start it at 0 because nobody's played yet. And each of these things are just properties on our tic-tac-toe object, right? Cool. Step 6, select the grid element using a grid selector property set on the options argument or using a default CSS selector. So we're basically giving them the option to pass the element they want to use as their grid, or we're going to provide a grid for them, okay? So that's basically it. We're going to default to one or the other. So we're going to say this dot grid equals document. And then we're going to take advantage of how the interpreter reads, because we're going to run out of room off the side of our screen. So we'll come down. We'll just move in a couple of lines, a couple spaces. We'll do query selector. And then inside these brackets, we're going to perform a tiny little bit of logic that basically says if there's a grid selector already being passed through the options, then use that. Otherwise, use this. So we're going to use that wonderful OR structure again because, I mean, writing a whole if condition just seems pointless, right? So I like to wrap these in a set of parentheses. So I put a set of parentheses inside the parentheses. So you'll wind up with 2 of them. I'll scroll up a little bit so it's a little easier to see. The first piece is options dot grid selector, which will just be a string that will come from that options property that's getting passed. Or the wonderful double pipes. I think JavaScript even supports the OR keyword if you really want to use the OR keyword. And then, like I said, it's just a string. The one we're going to default to will be hashtag grid. Currently trending. All right. You guys are super tired, I can tell. Just like, make with the tic-tac-toe already. Okay, so we've got our grid, right? Which is basically like our game board. I'm just going to scroll up a little bit. There we go. Hopefully you can still see that okay. Step 7, select the messages element using a message selector property set on the options argument or using a default CSS selector. The reason why we keep doing this is because we're giving them the ability to choose the elements they want to use to put messages in, to use as a grid, to define their player pieces, all those type of things. We're basically taking this thing and making it extensible, able to be used by other people for different reasons, right? And that's the way you should constantly be programming, with the idea that your particular library may be utilized by other people, so you should give them options. All right, so this dot messages equals document dot query. Whoop, now I'm going to move dot to the bottom. Dot query selector. Otherwise, it's going to get very hard to read. And we're essentially doing the exact same thing we did here, right? So put in another set of parentheses in there. You don't have to, though. It will interpret it. I just do it for my own personal peace of mind. And here we go. Options dot messages with an S selector, all one word, or hashtag messages. So that will select the messages input element that's sitting on the page. It's that little block that's just underneath the blue box. Or it's whatever they chose to use it with. Because at the end of the day, all they need to do is take this JavaScript and plug it into whatever HTML page they have, set up a couple of options, and they can use it on their HTML page, right? All right, cool. I'm going to scroll up a little bit. Step 8. Check for the method buildGrid on the tic-tac-toe object and call it if it exists. Now, the reason why we're checking to see if it exists first is because it will blow up if it hasn't been defined, right? We can't call something that doesn't exist. So we want to make sure it exists already, and then we'll call it. And we're going to use another piece of shorthand, right? So you learn the OR shorthand. This time we're going to learn about singular line if statements. If statements can be written on one line if they only have one expression or one statement afterwards, which can make it very easy to read. So we're checking to see if buildGrid exists as a property on the tic-tac-toe object. It will be a method that we will define, but we're not going to call it. We're not going to use the parentheses, otherwise that will call it, right? And it'll just return back undefined on us. So we want to make sure that we don't do that. We're going to do this. If it exists, then we're going to call it this.buildGrid with the parentheses. So what this basically does, it checks this condition. If this condition is true, it will execute this part. Okay? Many JavaScript programmers hate that. They hate the way that reads because they find it very difficult. So they still keep the shorthand, but they move it to the next line so that it shows that this is the next statement that's executing. Now here's something of interest. If you were to write this, breaks it a bit. If this statement is true, right, this will execute. If this statement is false, will this still execute, or does this have to be true? How many people say that this has to be true in order for the console log to execute, just out of curiosity? Okay. How many people think this has to be false in order for this to execute? How many people think it doesn't freaking matter, it's always going to execute? Okay. That's exactly it. This, when you write it shorthand like this, without the curly braces, without the block, you can only get away with one statement. That's it. Just one statement, one magical statement that you can execute. If you have more than one statement in here, every statement afterwards will just execute normally unless you wrap it in the block, right? So you can only use this shorthand if you're like, check, run. That's basically all you're doing. Check and run. Cool. So write that however you want. If you really, really are like, dude, I hate this, then add in your curly braces if that feels better to you. Okay? Or embrace the shorthand. Boom. There we go. All right, next. Step 9. Select the generated cells that are in the grid using the CSS selector. Okay. So we're going to say this dot cells. Now, this dot cells is going to actually get built by, what the heck? There we go. This dot cells equals this, that's not how you spell this, this dot grid dot query selector all, because we're going to select a whole bunch of them, dot cell. Okay. So the idea here is that the build grid will create a whole bunch of cells and put them inside our grid. Okay. The last piece here will select all those cells and store it in a property on our tic-tac-toe object that we now have access to throughout our application. And that is it. That's the tic-tac-toe main initializer built. Our constructor is built. A little confusing. Make sure you guys take a look over it. You know, when you're doing your studying, and I know you all do, take a look over it. Anything you have problems with, please make sure you contact me and ask. Now we're going to get into doing some prototype stuff. We're going to create a build grid method on the tic-tac-toe object. And in order to do that, we have to utilize the prototype property that we learned about before. Once you do these a few times, you're going to be just so used to it, you'll just immediately write prototype every time you want to create a new method, right? So let's do that now. We're going to do tick, tack, toe, which is the object constructor above, dot prototype, and then whatever we want to call our method. And our method's going to be called build grid. Okay? We're not done yet though. All we've done is created a property on the prototype. Now we need to make it equal to a value. So we're going to say it's equal to function, right? So it's going to be equal to a function definition. That's what we're basically doing. So build grid is going to become a method on the tic-tac-toe function, which will be kind of cool. The nice thing about this, the reason why this exists is because, say Goggendeep wants to take my tic-tac-toe and add an artificial intelligence to it. She can do that very easily, but just adding a new prototype method, call it AI, and write her function for it. Or, you know, say Lulu wants to take that whole tic-tac-toe function and write difficulties, like an easy difficulty, a medium difficulty, or a hard difficulty, right? She can go ahead and do that. Or Caval wants to actually build machine learning into it and write machine learning into the core of it. He can do that easily. And the best part about it, you're not ever actually affecting the core of it in any way. You're just simply adding new methods to the prototype that can be utilized by the whole object, right? Makes it very extensible. Cool. So let's go to step 11. Step 11, clear the grid's inner HTML. Remember that inner HTML property we were talking about before? We're going to do that. We're going to do that by doing this dot grid, which was defined in our initializer, right? This dot grid dot inner HTML. Make sure you write HTML in all capital letters. Equals either an empty string or, I kind of like Caval's method, null. I mean, it's clear, crystal clear what you're doing there. It's not empty. It's not anything. Cool. I think this is a good time to like jolt to the bottom of the page, click execute so it saves everything. Bam. And then we can come back up if we can find it. There it is. All right, step 12. Set a counter variable called index counter and initialize it to 0. Alrighty, so we'll do that. We're going to say let index counter. So as you'll notice, I'm not using this because it's not a property on the function constructor. It's essentially like a throwaway variable. We're going to use it, abuse it, and then get rid of it. That's it, basically it. There we go. Let index counter equal 0. Step 13, create a for loop that will iterate a total of 3 times. So now, the name of this function is called build grid. So I'm sure you can guess what's going to happen. We're going to do an iterator for 3 times. And then we're going to do another iterator that iterates 3 times, right? So essentially, we'll have 9 iterations altogether that will occur. And those 9 iterations are going to build our little cells, right? So let's do that. So we're going to do for, I mean, you guys know how to write these, right? I equals 0. If I is less than 3, I plus plus. You can do that almost in your sleep now. Cool. Under step 14, we're going to initialize a row variable and store a new div element inside of it. So we're going to say let row equal the very thing we learned today, document.create element, and we're going to create a new div element to go inside there. And I mean, we can clean this up a little bit. There we go. That looks a little cleaner. Under step 15, we're going to actually add a class to this new div that we created, right? And we're going to do that by just saying row. We're going to access a property on it called class list, which literally stores all the classes on it, right? Now, when I say class, I don't mean like a programming class. I mean like class, like a style class, okay? So the class list dot add, and add will take any number of classes that you want to add. We're only going to do one, but you can literally comma separate them and add as to many as you want. So that's creating a brand new div and adding a class called row on it, and now it's just sitting. Is it a part of my DOM yet? The answer to that is no. It is not a part of the DOM. We haven't appended it yet. It's just floating in the ether, right? All right, let's come down to step 16. Create a for loop that will iterate 3 times. Well, we're creating this for loop inside a for loop, which means we're going to have a total of 9 iterations when we're done, right? Make sure you don't call the variable I. We want to call the variable j, because we don't want it overwriting the other I, right? If j is less than 3, j++. Matrix math, and I think that's where this comes from. In matrix math, in order to define your grid like this, they use I, J, and K. That's what they use. So it's often when you see programming and people are doing nested loops, you'll see I, J, and if they nest one more, you'll see K. It's just generally the ones they go to. I mean, you can literally call it anything you want. It doesn't matter what you call it, but that tends to be the ones that they use. And interestingly enough, it comes from matrix math. All right, let's move all the way over here. Now we're going to say, let's create a cell. So we know how to do that. We're going to create cell equals document. And what's the method I want to call? Yeah, create element. And we're going to make a div. Okay. Once we've done that, we're going to add a class to it. So we're going to do cell class list dot add cell. We'll just call it cell, might as well. Make it nice and clear, easy to do. And now I have a cell. In fact, I have 3 cells, and I have a row, right? And I want to take those 3 cells and move them into the row. So basically, each iteration when I create a cell, I want to append it to my row, right? So I'm going to basically create a row with 3 cells in it. And I'm going to create 3 of those in total. So we'll wind up with a grid of 9, right? So in order to do that, we're going to append the cell to the row element we created above. So we're going to say row.append cell. And there we go. We now have a cell sitting in a row. And we're going to do that 3 times, and then we're going to move to the next row and do the same thing. Now the cell is the thing that the user is going to interact with, right? When I want to play tic-tac-toe, I don't want to have to be like, okay, start here and go to here. So we're going to say move to column 2, row 2, and write a 4 in there, because that's goofy. I mean, I have JavaScript. I have events, baby. I can click stuff, right? So I want to use clicking things. So I want to go and say, now write something there. So I can do that by creating a click event. So this is like your first intro to actual event binding, right? Next week, we're going to do lots of event binding. But this week, we're going to only do 1 event binding. So come down here. First thing we want to do, there's a whole bunch of instructions there, but in a nutshell, we're going to do our if this.processBoard. So we're going to check to see if a function exists called processBoard. Well, actually, we're just checking to see if that property exists, right? If this property exists called processBoard, and I'm going to move down here to the next line. I'm going to write cell.onClick. OnClick is a property that is available on every HTML element on the page. I didn't make this property up. It exists. It's a thing that exists. And basically what happens is when you click like this, it does 2 things. 1, it looks for anything that is currently bound to the onClick event of that HTML element. and it will look under the onClick property. It will look for event binders that have been added to it, which we'll talk about next week. It will look everywhere till it finds something, and if it doesn't find it, it's going to move up the chain. So if it doesn't find it here, it's going to move to the whole thing and say, do you have an event called onClick? No? Cool. It moves up further, checks the body. Body, do you have an event called onClick? No? Cool. And it moves up even further to the HTML element, the whole wrapper, and says, do you have an onClick called onClick? Like, do you have an event? So it bubbles. It's way up through the chain. So we only want one here. And we want it to basically stop here. So we're going to say cell onClick equals this dot process board. And incidentally, like your question about the arrow functions, we're going to find out why arrow functions are a little nicer than this, because unfortunately, we need to tell process board that it belongs to the tic-tac-toe function. Right now, it doesn't know it belongs to the tic-tac-toe function. It thinks it belongs to something else. So because of that, we have to add one more chain here. We have to do dot bind and pass in the context of this to it. Because when we actually go to call process board, it's going to be in a different function, and it's going to think its context is that function, which means it won't execute properly. Don't worry if you don't understand what this is doing. We will be talking about it over the next couple of weeks. It is a bit confusing and becomes more prevalent when you're doing events. Not something you have to do tons, just here and there. Alrighty. Cool, so checking to see if process board exists. If process board exists, we're going to define an onClick event on the cell. That onClick event is going to be equal to this definition, and we're binding the context of our whole tic-tac-toe function to it. I'm going to make it sound so simple, but I get that it's a bit confusing. Step 20. We've got one row, right? We've moved out of our cell. We're in one row. Now we need to take that whole row and we need to append it to the grid, right? So we're going to say grid dot append row. And actually that is, yeah, that's correct. Because this silly curly brace that's over here is actually the end to the cell loop. There you go. And this would be the end to the row loop. There. Might be a little bit clearer. So we've created a cell. We're going to go back up, create another cell, go back up, create another cell. We're done. We move to the next line. Now we're going to append our row, move to the next iteration. Cell, 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 row. Cell, 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 row. Done. Exit our function. Right? Cool. Step 21. Add the process board method to the tic-tac-toe object and pass the event through as an argument. Now didn't I call it process game or evaluate game? What did I call it in the number guessing game? I can't remember. This is basically the same function. It's going to check for a win condition is essentially what we're doing. This is the guy that's going to take care of most of that type of logic. Did they win? Is it currently in a draw? Which player is up? It's the one that's basically the operator, the switchboard that's going to take care of all that processing. So we're going to add that method on. And again, this is just going to be another prototypal method. So tic-tac-toe.prototype process board equals fun function. Only this time, we're going to give it a placeholder property. We're going to give it a parameter, and I called it E, but I think for clarity, I'm going to call it event. When I take my large fat finger and I go bam, what happens under the hood is JavaScript says, whoa, a click has occurred. Now I'm going to take that click that you did on this cell and I'm going to tell cell that you clicked it. Oh, you have a function in there. Awesome. I'm going to take this whole thing that you just did, this event that occurred, and I'm going to pass it to your function. If you have a placeholder in there, whatever you want to call this, Bob, Charlie, whatever, it doesn't matter, or event, which would make more sense. If you have a placeholder in there, it will store that event information into there. And that event has tons of crap in it. I mean, like, this is like a thing that has like 100 properties in it. It's so big. It has exactly where the mouse event occurred, like the XY coordinates of where the mouse event occurred, the time that it happened, how long you actually depressed your mouse for. All of that information is sitting inside that event, including the target that you clicked. It knows what you clicked on. It records all of that information and passes it through this event object, which you now have access to do whatever you want with. And we're going to utilize it for sure. First thing we're going to do before we play around with that is we're going to call play piece if that function exists, right? So we're going to say if this dot play piece. So if that method exists, then this dot play piece. And I'm going to move that to the next line just to make it a little easier. And play piece is going to take advantage of that event. So we're going to pass that event to it. So if the play piece method exists, we're going to call it and we're going to pass the event that we got from the user off to it. After that's done, we're going to actually check to see if there's a win condition. So we're going to play the piece. So if it's like, we've got our grid, right? Our user has clicked here. We're going to play the piece. We're going to call this play piece function. This play piece function is going to do a few things. It's going to check to see which player is currently current. That player that's current, we're going to play their piece. So for the first person, we're going to play their piece, right? Then we're going to check to see, is the game done and has somebody won? Not likely, right? Then we're going to wait. Next person's going to click, right? Cool. We're going to draw their piece because we switched players now. And we're going to go through. That's the logic we're building. All right. So step 23, call check win on tic-tac-toe if it exists. So if this dot check win, okay, and we're going to do two conditions here, and this dot check win the execution. So the first one's checking for the function definition. The second one is actually doing the function call and evaluating its return. Okay? So if they have the definition defined, and if it returns back true, step 24, I'm going to come down here to the bottom. We're going to set the messages text content to be the following. So we're going to say messages.text content equals, and I mean literally just copy and paste, right? Command C, Command V, throw in a semicolon. There's our text content message. We're super close. I'm going to scroll up a little bit. Step 25. So we've defined the message that that player has won. So it makes sense, right? If we're playing our game and the player has played their piece, here's X, there's O. It's my turn again, so I play X. They play O, right? So now I'm ready to play my piece. I click here. I play an X. It checks to see if there's a win. Check win returns true. Yep, this person won. Then that's going to come through and it's going to say player, this current player equals 1, has 1. So what it's going to do is basically go through. That shouldn't be equals 1. That should be plus 1. That is incorrect. Because remember our players are 0 indexed. So if it's currently 0, if current player is 0, it's going to say player 1 has 1. If the current player is 1, then it's going to say player 2 has 1, right? Otherwise, meaning somebody hasn't won, right? So else. set the, oh no, sorry, I am wrong. It's an else if. Otherwise, we're going to check, throw you for a loop, check if the plays count is equal to 9. Why am I checking if the plays count is equal to 9?
Or they might withdraw.
Right, exactly. It's a stalemate. It's done deal, right? Game can't go any further past 9. So if this plays equals 9. All right, then we're going to set the message. Messages dot text content equals, and just copy and paste. Paste it. Semicolon. There are no more moves. We've reached the limit. Otherwise, our last else. If nobody's won, and the game is not in a draw, then obviously we can still do what? Exactly, we can switch the player because we can still continue to play. So that will be our else. We're going to say else, change player if it exists. If this dot change player, then this dot change player. And I'll just put that to the second line because it just makes sense for readability. Now, you may be asking the question, why so many methods? Why do we need a method for literally every tiny little thing? And the reason is because by doing this, we're encapsulating logic specific to that thing in one tiny area, and it can grow, shrink, be maintained quite easily, be adapted, right? Somebody can write their own new prototypal method that overwrites the change player functionality and allows for 3 players to play tic-tac-toe, right? Or anything else they may want to do. So we're keeping that extensibility and yet making it nice and maintainable. Alrighty. So that is it for the process function. Definitely a good point to save. So let's come down, click execute so that we save our current logic. Does anybody need a break? Are you still good to power through? All right, cool. Let's continue going. Step 28. We're going to create a new method called playPiece on the tic-tac-toe object and pass the event as an argument. Now this is literally the 3rd time we've done this. Should be coming old hat at this point. Tic-tac-toe dot prototype dot playPiece equals fun function. Bam. Don't forget, though, we want to pass that event to it. Remember, we called the event in the above part, and we passed it on. We're going to pass it on through here. Because that event object, that is a beautiful chunk of an object that contains so much wonderful information, and we want to be able to use it. Think of it from this aspect. I have 9 possible points of events, right? They can click any 9 of these squares. And when they click it, I want to know which one they clicked. I currently have no context. I have no idea which one they clicked. The only thing that tells me which one they clicked is that event object. It's the only thing that contains that information that gives me any, insight to what they've actually done. So we want to maintain that little fella all the way through. So we're going to write in condition. If the event's target text content is empty. So if, and we're going to write event.target.text content equals empty string. So let's talk about that real super fast. I want to see how good your Sherlock Holmes skills are. Okay? Text content is a property of what type of object? No. Think about our DOM, right? And the objects that our DOM utilizes, right? Which DOM element has text content on it? Kind of gave it away with the last word there.
It's values.
What's that?
Usually it's change the value. So
Either value or text content. You're on the right track. You're thinking about it. The HTML element, right? That wonderful object that we keep selecting with query selector. Event target, that's what it's returning. It's returning an HTML element. This corresponds to whatever you clicked. It returns back what you clicked as an HTML element. It's like it's calling document query selector on that exact thing you clicked on. It returns it back. Because it's an HTML element, you can now access any of the properties on it, any of the attributes, access its styling, you can change its color, you can modify it in any way you choose because it's just an HTML element that comes back through that event. Super cool. All right. And don't worry if you're not fully clear on that. You'll become clear over the next week because we're going to be doing this a lot. All right, so event target. We've got it. We're going to add one to the plays property. So we're going to say this dot plays plus equals 1. So that basically takes plays, adds 1 to it, and restores it back into plays. That's what plus equals means. Another little handy piece of short code that you can write in literally every programming language ever, including annoying languages like Go. All right. Step 31, modify the target's text content to be the current player's piece. That makes sense. We basically want to take whatever the text content is in here, right? Because we basically said, are you empty? Yes, you are. So now we want to actually fill it with a piece, right? So they click. This is literally what's happening. They clicked. We evaluate it. Has the game been won? Nope. Has every single board piece been played? Nope. Cool. Let's play the piece. I'm going to write something in here. Oh, is it empty? Yeah. Cool. So I'm going to write the piece into play. Okay. Cool. So we're going to say event.target.text content. Remember, event target is just an HTML element, right? It's the HTML element that you clicked. Equals this.player pieces. Remember that thing we defined way up top? This.current player as the index. That's why we're using 0 and 1 as our player indexes, because it makes it very easy for us to access their player pieces. Just as a side note, while people are writing that, this isn't from anywhere. I didn't go to the internet and go look up some guy's tic-tac-toe board and figure it out, right? This is off the top of my head, last Saturday, just writing it out. Shit broke, fixed it, right? That's literally all it is, trial and error to figure out what the logic is. And it's not concrete. Like, this is not the best logic. Like, for example, once the board is full, you can still click things. You shouldn't be able to, right? It should reset the board and things like that. But it doesn't, right? It's not keeping score. It's not doing anything fun outside of that. But, I mean, you can expand on it at any point. The reason why I'm bringing this up is because that's what you guys should be doing as programmers. Challenge yourself when you have a bit of downtime. Like, maybe JavaScript's not your language and you want to do it in Java. But challenge yourself, especially with crap like games. Because games force you to use strange architecture. And they force you to think in a way that you don't generally think, right? When you're dealing with data, data is straightforward. User creates input, I store input. User wants to modify input, I pull input, modify input, restore input, right? Straightforward, not a lot of thought process, and anybody can do that. But working like this forces you to think about architectures that you don't generally think about, forces you to utilize coding paradigms that you don't generally use, and it keeps you practiced, right? So that's, if you love programming, and I guarantee there's people in this room that don't, but if you love programming, that's what you want to do. In your free time, force yourself to create a tic-tac-toe game or Go Fish. And if you solve Go Fish, please let me know because I want to see how you did it because I can't seem to solve it. But Go Fish. Or like, did you ever play that peg game where you had to jump the pegs and at the end point you could only have one peg left, right? Try coding that. That would be a tricky one to code, but it would still be simple enough that you can figure it out for sure, right? Anyways, just my little 2 cents out there. Step 32, create a new method called change player on the tic-tac object. Well, we already know how to do these things now. Like I said, by the end of this, it'll be old hat dot prototype dot change player equals function. We're not passing an event object this time because we don't care about the event. This thing is literally going to use our wonderful shorthand that I told you guys in like week 2, I think it was. It's my favorite toggle shorthand. Does anybody remember what the toggling shorthand is? It's called something. It's a structure. It's a type of conditional structure. What's that? Ternary. That's the one. Ternary. We're going to do a nice little ternary here and make it switch our players for us. So we're going to say this dot current player. That's the variable we're going to store in, right? Write our condition. And I like to kind of write this out like this because then I can see each of the pieces that I need to do, and then I start filling in my stuff, right? So I'm going to come between my parentheses here, and I'm going to say this dot current player, because this is where my condition goes, is equal to 0. So I'm basically saying, is the current player index 0? Because if it is, what am I going to do? Change it to 1, right? We're going to toggle it. And if it's 1, I'm going to change it to 0. Actually, I think 0 evaluates as false. So you could try, and it might work. If you did it with the bang operator in front of it, it might evaluate as false instead of having to do equals equals 0. Maybe. It might not work. I'm not going to bother playing around with it, but it's a bit of my ADHD kicking in there. All right, step 34. Create a new method called check win on the tic-tac-toe object. I mean, we can literally do this in our sleep by this point. And this one's got quite a bit of logic in it, but it's literally the last method we're coding. We have no more methods after this one. Step 35, iterate over the win conditions, casting each element into a variable condition. Well, I can use a standard for loop, but what is a better loop to use with arrays? Still a for loop, but it's not a standard for loop. It's a for each would work too, but there's a better one that came with ES6. For let condition of. The for of loop. Beautiful loop. Actually, much more performant than the for each loop is. Definitely a better way to go. Reads better too. Way better. Yep.
Do you pass any arguments for the checklist?
What was the argument for it? I don't have any arguments listed. There is no arguments for it. Yeah, so no. Yeah, there's no parameters for check-win. Check-win is basically what it's going to do. I like to call them dumb functions because what they do is they don't need any information. They're just going to go out, they're going to evaluate the board, and then they're going to come back, and based on that evaluation, they're going to come to a conclusion. Did you win? Sure. Or no. That's literally what it's going to do. Yes or no. All right, so we're going to iterate through those win conditions. And this logic is a little complex, I will admit, just because it's a bit hard to wrap your brain around it, but we're going to check the piece count. We're going to set a variable called piece count, and we're going to make it equal to, and I feel a bit sadistic about this, I apologize, condition, which is an array, right? Remember, we're going through that those wing conditions, which was an array of arrays. So each condition is an array. It's a possible wing condition, right? So think about all of our possible wing conditions. Each condition is one of those possibilities. So because it's an array, I have array methods available to me, and I'm going to use them. I'm going to call dot filter. I'm going to call function inside there because I'm going to pass it a callback. And see this last parenthesis next to the curly brace there? Just take it off. Okay. Cool. Just before this one, we're going to write return. And we're going to return whatever the evaluation between those parentheses are. Like I said, this logic is a little different than what you're probably used to. Definitely evaluate this stuff on your free time. All right, we're going to do this dot cells. Remember how we stored all our cells, our 9 grid? We're going to grab our 9 grid. We're going to take this index that's getting passed, because essentially what's happening, filter is going to call this function, and each iteration it's going to pass whatever the value is that it's on into this argument. So think of all the wing conditions. The first time it passes, 0. The next time it's going to pass 1. Then the next time it's going to pass 2. Then the iterator is going to come back around, and it's going to do 3, 4, and 5. Then it's going to do 6, 7, and 8. And then blah, 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 and then blah, and then blah. Okay? So it's going to overview each one of those things. So you're going to pass index in there. You're going to call text content on it. You want to basically check to make sure they're not empty. Whoa, what was I writing here? Using index reference cells of that index and check to see if the text content is empty. Let's see here. Oh, I see what I'm doing. Right. This is a bit bizarre just because I spaced it out. I spaced it out because I wanted to keep the commenting in. Remember how I told you the interpreter will continue parsing till it gets to the next logical exit point? This will actually continue parsing through this comment until here where we evaluate the next condition. I don't know why I wrote it like that. It's kind of a little bit wonky to read. We're going to check the cells condition 0.text content. Yeah, I'm scrolling up. I can see you stretching. Equals this dot cells index dot text content. Whoop. Yeah, text content. Sorry, there's no curly brace there. All right, I'll explain what's happening here. On this filter, the way filter works, you guys might remember this from writing your filter function. The way filter works is it evaluates whatever's inside, and if you're returning true, it will return back whatever element it's currently working with. So if you return true inside the body of the function, whatever element is currently being passed in immediately gets returned back out. The reason why we're doing this is we're going to basically check and say, hey, is this cells.text content empty? Is it empty? Is there nothing in it? Sorry, not empty. We want to make sure it's not empty, that there's an actual value inside that cell, right? Then we're going to say, and this condition's 0. So we're just grabbing like the first one of these cells, right? dot text content is also equal to the current index you're on's text content. So it's kind of a bit redundant, and there's probably better logic out there. Basically, the first time it iterates, it's going to say, what's in you? Are you empty? No? Cool. If you're an X, are you equal to yourself? The first iteration? Well, yeah, obviously I am. Cool. Are you equal to the next index? Sure. Okay, cool. Are you equal to this index? Yes. That's a win. Pass it back. That player has currently won. If it's a no, then it's going to move to the next win condition and do the same thing. And it's going to do it through each win condition until it finds a winner. If there's no winners, then it's just going to come back and say there's no winners. Right? All right, step 39. We're almost done. We're like very close to the end of this thing. Step 39, bind this. Yeah, bind the this construct. This is annoying. Dot bind this. And the reason why we're binding this is because, is it the right spot? Yeah, that's the right spot. The reason why we're binding this is due to the context of this. We need to make sure that the tic-tac-toe function is being passed through it. I realize I'm glazing over that. We will be taking a look at this in a more simplified version, so it's easier to understand in the future. All right, step 40. Step 40. Return true if piece count length is equal to 3. So all of this, when it's finished, is literally going to store inside that variable 3 values. Only if all 3 values are the same value. If they're not, then there'll be 2 values in there, or 1 value, or 0 values. If it's 0, 1, or 2, that's not a win, and it moves on. If it's 3, then it's a win for sure. So that's literally what we're going to do. We're going to say if piece count dot length is equal to 3, then just go ahead and return true. Meaning it's 1. You won. Otherwise, if it makes it through all of that and you didn't win, then it's a return false, right? Which means there's no current winner, so we return false. And guess what? You're done. You did it. That's the whole tic-tac-toe game. All 179 lines. In fact, I think the number guessing game was shorter. The one that you did for the assignment. All right. We have one more line to write because this is a function constructor. Is this working right now? What do we have to do to get it to work? Yeah, we have to call it. We have to call new tic-tac-toe. Here's the cool thing. If you throw an object in there and change the player pieces, it will take those into account. If you put a new element in there as the grid and choose a totally different div element, it will use that now as that grid. Right? This is an entirely extensible application. Go ahead and click execute. If everything is golden, you should see a lovely tic-tac-toe board here. And it should function. Player 1 is 1. If you don't see the tic-tac-toe board, that's totally fine. Feel free to copy and paste to your lab for full marks. Even if it doesn't work, that's totally fine. Just paste it and I will give you full marks. But what I would like you to do on your own or with a partner or whatever, figure out what went wrong. Okay? Challenge yourself to fix it. Because it's probably something very small, some tiny syntax error, right? If I do Command-Alt-J, I don't have any errors. But you will likely have an error in your console if there is one. Lulu, did it work?
No.
No? Did anybody's work? Really? We're all coding the same thing. Did yours work?
Yes.
Yeah, there you go. One person worked. I mean, I only have to get one working. No, I'm joking. All right, let's take a look. We'll pull open this code. There we go. All right, where's a good place to post this? I think the best place to post this is probably right directly in here. I'm going to add an item. Paste it in there. Wow, that is garbage. Why does it paste like that?
Because it-
That is stupid. All right, I'm going to do Command-Shift-S. Save that to the desktop. Browse my computer. Desktop. Oh, right, name. Tic-tac-toe complete. All right, under the weekly learning, there is the tic-tac-toe file. Here's what I'd like you to do. Take that file, download it, right? Create an HTML page with a grid on it, and run it. And then compare yours to it and figure out what you did wrong in yours versus it. All right? Your best bet is to start with your console and try to use your console to help you fix the problem. That's the first place to start. Yes, Kamal?
It's like it didn't even show any error on the console.
But you still don't have a grid?
Yeah.
Did you click execute when you got to the bottom? All righty.